In this video, we're going to learn about complex rational expressions. This video will be mostly examples of how to do them by these two methods that we'll learn. So the first objective is to learn how to use division to simplify these. And the second objective is to learn how to do them by multiplying by the LCD, or the least common denominator. So when we simplify it by dividing, what we need to do is get a single fraction or rational expression in the numerator and a single rational expression in the denominator, and then we know how to divide rational expressions, right? You keep the numerator the same and you flip the denominator and make it multiplication. And then we do all the simplifying we can, and then we're done. So let's look at a few examples of these. Now these are not examples I'm going to write. These are examples that are going to come up on the screen as text. So we'll see if you like this method. So the first example we're going to look at is this rational expression, which is x over x minus 4, that's the numerator, over 3 over 2x minus 8. That's the denominator. Well, that's a single rational expression in the numerator and a single rational expression in the denominator, so we don't have to do anything to get that. So what we're going to do is we're just going to rewrite this using a division symbol instead of a fraction bar. Now it looks more like a problem you've seen before, and we know that we can keep the first rational expression the same, change to multiplication, and flip the second rational expression. And then when we do the multiplication, we're going to factor that 2x minus 8. We're going to factor that 2 out, because then we'll have an x minus 4 in a numerator and an x minus 4 in a denominator. We can go ahead and remove those because that is a factor equal to 1 at that point. And what are we left with in the top? 2 times x, 2x. And what are we left with in the bottom? 3. So our final answer when we've simplified this is 2x over 3. Now our next rational expression, complex rational expression that we're asked to simplify is not quite so easy, because there's 2 terms in the numerator and 2 terms in the denominator, and we have to compact those into single rational expressions, both top and bottom, before we can proceed. That means we have to find common denominators for the top to combine those, and a common denominator for the bottom to combine those. So here's what it'll look like. Our common denominator for the top rational expressions is 3. We have a 5 over 1 and an x over 3. The least common multiple of those is 3. So we have to multiply 5 times 3 over 3, our convenient version of 1. And in the denominator, you'll see that our common denominator is 2x. So we'll have to multiply the first rational expression, 4 over x, by 2 over 2, so that that denominator is 2x. Okay? So that's all we're doing is multiplying by a convenient version of 1 to get the LCD. And that'll get us 15 over 3 plus x over 3 in the numerator, which is 15 plus x over 3. And we'll get 8 over 2x minus 1 over 2x in the denominator, which will give us 7 over 2x. Now we are at the point where we have a single rational expression in the numerator and a single rational expression in the denominator. Okay, so there's just showing that last step again. So now what we're going to do is we're going to rewrite it with division. And then we're going to keep the first one, change to multiplication, and flip the second one. So this is what we'll end up with. There's no common factors anywhere in anything here. So all we're going to do is do a straight up multiplication. That means distributing that 2x and multiplying the 3 and the 7 together. So we'll get 30x plus 2x squared over 21. Now, there's a second way to do this, and the second way to do this is to just get rid of fractions altogether. And the way we do that is we multiply every single expression by the least common denominator of the entire thing. Once we do that, we don't have any fractions left, and we should just simplify and factor if possible. So here's a few examples of this. Okay, we're going to simplify 1/2 plus 3/4 over 2/3 plus 1/4. So we'll look at those and we'll see 2, 4, 3, and 4 are my denominators. So my LCD is 12. So I'm going to multiply everything by 12. Okay? The way they put it, and this is really important to understand, is that we're multiplying the expression by a factor equal to 1. It's 12 over 12, and that 12 gets distributed into both terms of the numerator, and the 12 gets distributed into both terms of the denominator. But we have not changed value because we are multiplying by a version of 1. Okay, so now they're showing that last step again. So now, let's take that 12 into each of these using the distributive law. And what do we get? Well, 1/2 times 12 is 6. 3/4 times 12 is 9. 2/3 times 12 is 8. And 1/4 times 12 is 3. So 6 plus 9 over 8 plus 3, which is 15 over 11. And we're done. That's the final answer. This next one has denominators of 1 and x, both top and bottom. So our least common denominator is going to be x. So again, we're going to multiply the entire complex rational expression by 1. But the version of 1 that we're going to use is going to be x over x. And we're not going to forget to distribute that in. That's going to multiply by each term in the numerator and each term in the denominator. And what does it do? It clears out all of our fractions. So what we're left with is x plus 1 over x minus 1. No common factors. Remember, those x's are not a common factor because they're each part of a binomial expression, and those binomials are the factors. So we cannot cross out the x's. So that is our final answer. The last one we're going to look at looks a little bit more complicated, but it's really not, because we still have single powers of x. They get more complicated when you have binomials. Okay? But we're still just into single powers of x. X cubed, x squared, x, and x squared. What's the LCD? Well, the LCD is x cubed. So again, remember, we're going to multiply the entire complex rational expression by 1. The version of 1 we're going to use is the LCD over itself. And we won't forget to distribute that in so that each and every term gets multiplied by that x cubed. And what we're left with is 6 minus 2x over 3x squared plus 4x. Now, you could have left it like that, or you can go ahead and factor it down because you realize that both of those expressions do have the ability to be factored down a little bit further. But what you find when you do that factoring is they don't have common factors. So it does not help you to do that factoring. So either version of the answer, either this one or this one, are perfectly acceptable answers.